Joining. Today's webinar is titled "Designing Homes for Designing Designing Climate Resilient Homes for a More Sustainable Future." This is part two. If anyone wants to see part one, definitely reach out to us. We can send you the recording from the first session. This presentation will cover a lot of the content from the first, but also a lot more. And yeah, here's today's agenda. Oh, first about me. So my name is Daniel Salinas. I work at cove as a research mechanical engineer. Before that, I worked at Arup as a mechanical engineer for 2 years. And then before that, I graduated from the University of Texas at Austin. So if anyone's from UT, welcome. And so now I'm going to continue. So today's agenda, I'll be covering climate resilience and sustainability, and then future construction methods and affordable housing. And then at the end, we'll have a Q&A. And the reason why I'm for a presentation that's really about the future of residential architecture, the reason why I'm talking about climate resilience and sustainability as the first topic is because that's kind of what everything's really revolved around. I mean, it's a big aspect of it. There's also like affordable housing and other parts that, that the future of architecture kind of ties into, but climate resilience is so important because, what's waiting for us in the future is going to be, climate change and all of the effects of that. I see, Landy, you have your hand up. Is that intentional? I'm going to allow you to talk real quick, but just for the rest of the presentation, I'll just be presenting at the end. If you have any questions, just reach out. Do you have a question? I think I'm going to lower your hand. And then, so yeah, just any questions you have, just, let me know. I can ask you at the end, or you can ask me at the end. So first, climate resilience and sustainability. Here in this chapter, I'll be talking about climate change first, and then climate resilience and what that means, energy independence and electrification for buildings, and then passive systems and home automation. Okay. Next. So in order to understand what climate resilience is, we first have to talk about climate change. And in order to do that, we have to ask the question, so how did we get here? And so the answer to that question can be uncomfortable to some. The answer is we are responsible. That is, wealthy countries like the United States are responsible for climate change. Rich countries, including the United States, Canada, Japan, and much of Western Europe, account for just 12% of the global population today, but are responsible for 50% of all planet-warming greenhouse gases released from fossil fuels and industry over the past 170 years. The United States alone is responsible for a quarter of all carbon emissions, and those that are most responsible should be leading the climate change mitigation initiatives. So that's us, that's you and I. Us engineers in these wealthy countries need to do our best to combat climate change. And so what do we need to compare? What do we need to prepare for? Everything that's listed here. So there's like heat waves, wildfires, rainstorms, droughts, utility outages, winter storms, coastal flooding, high wind events, all of that. It's going to get really bad in the future. And it's already starting to get really bad. I'm personally not looking forward to the upcoming wildfire season that's going to start in like California. And also to zero in on the weather and climate related hazards that are relevant for a home's location, make sure that you check what types of weather events have caused damage in the region in the past, and consider the current trends revealed by weather observations, and also find out what climate conditions are projected for future decades. And so one way you can do this is by utilizing the climate impact map. It's an interactive map of the world that provides insights into the projected climate conditions per region up to the year 2100. So definitely utilize that resource. This is a link, but you can just search it up and find it as well. So how do we prepare? And so The answer to that is you design climate resilient homes. As architects, engineers, and contractors, our influence in mitigating and adapting to climate change is limited to the design of buildings. And since buildings account for 40% of global carbon emissions and we spend 90% of our time indoors, our influence is actually quite substantial. Society depends on its infrastructure, and it is our responsibility to design buildings that protect them from all possible threats. It's one thing to create buildings that aren't harmful to the environment, and it's another to design buildings and communities that protect and benefit its occupants now and for future years to come, regardless of changing climatic conditions. Smart, resilient design strategies are naturally dependent on the use of the structure, local conditions, and potential environmental threats. One size fits all resilient design is not practical. What works in California with its wildfires would not work along the Gulf of Mexico with its frequent hurricanes, nor on the East Coast where flooding and winter storms are becoming a serious problem. So that, this map kind of illustrates that, and each of these are different climate resilient home. Just be aware of this map and where your homes are located and design accordingly. But so what exactly is a climate resilient home? And we're going to kind of dive into that now. So the Intergovernmental Panel on Climate Change defines resilience in regards to climate change as the capacity of social, economic, and environmental systems to cope with a hazardous event or trend or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure, while also maintaining the capacity for adaptation, learning, and transformation. So climate resilience is the ability to anticipate, prepare for, and respond to hazardous events, trends, or disturbances related to climate. And improving climate resilience involves assessing how climate change will create new or alter current climate-related risks and taking steps to better cope with these risks. Climate change is a reality, and we now must all collectively face that, but how those rising temperatures will affect our livelihoods is still debatable. Sustainable housing alternatives will help us collectively reduce our carbon emissions to limit the long-term potentially devastating effects of climate change. And sustainable construction methods can help safeguard homeowners from extreme weather events. And what it's going to be this reoccurring theme in this presentation is that sustainable homes are green homes, in essentially, because if you look at the center of this graphic, which is the definition of climate resilience for residential design, you'll see that a lot of the, if not all of the points, kind of tie into green architecture as well. So that's important to make note of, because you can hit two birds with one stone with this approach. Seeing sustainable design as a necessary tool to creating a climate resilient home. So if you're going to create a sustainable home, might as well also tie in some parts of local climate resilience design into it as well. So, oh yeah, also each of the points here I'm going to be kind of touching on in independent slides. So I'm going to jump into passive building envelope. So passive strategies can go a long way in reducing energy demand and mitigating the need for active systems. And some simple passive strategies include massing and orientation to minimize heat gain and passively reduce energy demand, introducing external shading elements like overhangs, fins, and so on, and also increasing daylight penetration with strategic window placement, incorporating natural ventilation. And that one's a big one, but also keep in mind that with natural ventilation, you also have to account for, if you're in a wildfire prone area, just make sure that you have a filtration process ready to deal with that outdoor pollutant. And then finally, installing high performing envelope. This is a really big one. The reason why I listed this whole slide first is because a passive building envelope is the first defense mechanism against a changing climate. So of course, it's important to have efficient appliances and all of that, but if your home's enclosure can't adapt to changing climatic conditions, that's going to make it a lot more difficult for the systems that support that home to continue to support it over time. And so, you know, it's just really, it's like it's like carrying a heater with you, but without a jacket in the middle of the winter. That heater is going to be warm, sure, but it's eventually going to die and you're going to be without a jacket. So it's important to, you know, make sure you have a good passive, uh, it's called passive survivability for your building, just making sure it can survive on its own. Next is improved structural integrity. So like I was showing with the other graphic with the hurricane-proof home, if your building is able to withstand high wind events, then it's good to go to be built along the Gulf Coast. And so that's why the number one point is lateral bracing. Just make sure that you know, it's built to withstand all the conditions that it's going to experience in its lifetime. What's the point in designing a home that isn't built to withstand a hurricane if it's in a hurricane-prone area? It's like you're building a home for nothing, because it's eventually going to fall. And not just like, you know, in tens of years, it'll happen within 10 years if it's not built correctly. So just keep that in mind. The second is foundation. So there's this interesting, I didn't even know it existed until I created this presentation, but there's this new type of home called the amphibious home, and it protects against flooding events by, so the home is lowered into this, like this encasement, which is basically just like a foundation. And then in the event of a flood, the whole building floats and it just kind of rises out of that encasement. And then all of the ductwork, or not the ductwork, like the pipework that connects into the building, it's all flexible. So it's able to kind of expand in order to accommodate that you know, rise of the building. And so that's just like a new technology that I think it'd be cool to look into, especially if you know, your home's in a flood-prone area. But I guess there's other ways that I can imagine that are cheaper in order to deal with flooding. But and one of them is materials, which is the next point. So waterproofing your home is very important, but also fireproofing your building envelope for a wildfire-prone area. That's a big deal. So, and also there's other things you can do for a wildfire-prone area, is that, like, just make sure that your home has enough space between itself and the forest or whatever else is, you know, the environment that's around it. You all have seen, you know, different ways to clear the ground and all of that. But yeah, there's things you can do, and it's not just clearing the ground, but also protecting the home itself by making sure the envelope is fireproofed. And also a big point right here is, I kind of talked about it earlier, but yeah, passive survivability. So it's the ability for your building to maintain critical life support conditions for its occupants if services such as power, heating, fuel, or water are lost for an extended period. So, you know, like when you heard about the Texas winter storm where everything kind of shut down, those people that died, they would have had a lot better chances of survival if their home was able to sustain itself during long periods of cold, you know, by having a lot of insulation and you know, being built for that type of scenario, which most of the homes in Texas aren't, if not the rest of the world. They're not really built to experience that type of cold. But yeah, passive survivability is the first step to making sure that people stay safe. And also energy independence. So this is a big one. Independence from the local grid is a vital step towards climate resilience. And there's two parts of energy independence that kind of tie together, and it's energy generation, which would be, you know, your solar panels and your solar hot water collectors, but also your energy generation. So solar power is only, you know, it's only useful if the sun's out, but if you have a battery to back it up, then you can charge the battery, and you know, during the night you can still use the energy that you generated during the day. And same thing for the solar hot water collectors. Just connect it to a boiler system that can contain the heat, so you can use it in the future when the sun's not out. And also we do have inputs for that in cove, and that's kind of listed here. Oh, also a big one. So replacing gas appliances, and this is a big topic right now in the news, that especially with the war in Ukraine, everyone's talking about replacing their gas appliances with electric, and that's for safety reasons, but it's also to lower your carbon emissions. But you can only lower your carbon emissions by doing that if the energy grid is powered primarily by renewable energy. And so carbon neutrality in homes can only be achievable with energy independence and electrification. So if your home is independent from the energy grid, and it has on-site energy generation from that is easy. Am I still in the? It just told me I was signed out. Am I still here? Can someone leave a chat? Okay, great. I was freaking out. I'm like, what? Okay, thank you so much. Okay, so what was I? Yeah, that's essentially what I was just trying to say, is that carbon neutrality in homes can only be achieved with energy independence and electrification. And here's home electrification. So there's two components to this, at least for this slide. It's efficient electric appliances. So please stop installing gas appliances. There's already a lot of local governments that are slowly phasing out gas connections into homes. And also, if you're going to install an electric appliance, just make sure it's Energy Star rated. It has a high enough Energy Star rating, because the more efficient it is, the more the faster it'll pay itself off over time with saved operating costs. And another big thing to know is that electric appliances are better for indoor air quality as well, which is very important for our health. A recent study found out that children growing up in homes with gas stoves have an increased risk of developing asthma. So that's another reason why you should get rid of gas appliances, and also like gas boilers and all of that. That you just shouldn't have gas combustion going on in your home. It just doesn't make any sense. It's like having a barbecue inside of your building. Like, why would you do that? And also, yeah, the electric appliances are far more energy efficient at even like heating up food. Like electric induction ranges are much more efficient. So choose those instead of a gas-powered stove. And next is efficient HVAC systems. And so also I didn't talk about it over here, but it was gonna kind of be like a segue into the next slide, but heat pumps, that's a huge part of home electrification. So like I said, get rid of your boiler. If once it's time to replace it, just install a heat pump. It can either be geothermal or air source heat pumps. I personally like geothermal. It's much more efficient. It does have a higher upfront cost, but it is still much more efficient. And if it's cold outside, it's not as because air source heat pumps are very efficient, but for extremely cold conditions, they're not as effective, but they are still a great alternative, and they still will work. It's just the capacity won't be as high. So it might get a little bit colder in your home, but you can always back it up with like an electric filament that will heat up the air on its way into the house. So there's ways to make sure your home stays comfortable without utilizing natural gas. And so, yeah, that was a segue into this slide. The fuel type. So like I said, electric HVAC systems are much more reliable, cleaner, and safer. And also the type of HVAC system that you have is kind of have a huge impact on the comfort as well. So the way that you generate the heat, which would be your heat pump, that's one thing, but the way that the air is distributed, or like the way that the space is heated up, is another thing. So as you can see down here, this is kind of an example of underfloor heating. That's kind of known for being it's underfloor heating is famous for being one of the most comfortable space heating solutions, because you are heating up all of the area at the same time, at the same rate, and you're not having any cold spots, and so all the hot air just kind of rises from the floor evenly, and so it's just a better solution in my opinion. And so if you can afford it, definitely look into that. And then indoor air quality. So like I said earlier, if you are going to have ventilation via natural ventilation or any type of ventilation, just make sure it's filtered. And you can use either these air filters that you can install directly into your HVAC system, or if you are utilizing natural ventilation and you notice that there is the homeowner notices there is uh, uh, a forest fire, or it's just a really bad day for air pollution outside, then they can turn on their air purifiers. So there's always like a backup system to ensure that they are breathing in pollutant-free air. And then finally, energy recovery. So that's a big one. This one's a lot of people don't install this into their homes, and I understand it can be a little bit more expensive than the traditional installation for HVAC, but it saves so much energy that I just think it's a great solution. And then sensors and controls. So here are all of the different types of sensors that can go into a home, and all of them can be connected to a building management system, such as like a Nest. And a Nest, on average, does save up to about 10 to 12% on heating and 50% on cooling. So they can pay for themselves in about less than 2 years. So definitely make sure that if you're designing a home, just install a good enough building management system, such as a Nest, and also security systems. That's a given. Just make sure the home is secure as well. And here are some other examples of home automation. So facade automation is one of them. So here are some windows that open up by themselves, depending on environmental conditions. And so that allows for natural ventilation when it's appropriate. There's a window manufacturer called Window Master, and they're a Copenhagen-based company, and they have offices all over the United States as well. And they are a great a solution for homes. Harvard created a home that used them as an example for their home, and it saved a lot of energy. So that's something to consider. Also, reduce your lighting power density by installing LED fixtures. That's a big one. And also daylighting sensors, for sure, for natural daylighting. And then water security. We do have the water analysis tool at Cove tool, so utilize that. And just make sure that you're installing low flow appliances. If you can, gray water reuse for irrigation, rainwater capture and storage, and also, I'm not sure what this point was, irrigation, ignore that. So finally, I'm going to get to the future construction methods. And so this presentation was supposed to be 30 minutes, but it might end around 15 more minutes from here. But yeah, future construction methods. There's two different topics in here that I'm going to talk about, which are modular construction and 3D printing. And so a lot of these technologies already exist. It's just that I think that in the future, they're going to be a lot more robust. It's going to be it's going to be higher demand, especially 3D printing. And I'll talk about that soon. So modular construction entails sections that are manufactured off-site in a controlled environment, such as like a factory, and then brought to the site for assembly. And some advantages of that type of construction are faster project turnaround, improved structural integrity. It can be utilized for either single family or multifamily housing, better quality control because of the factory floor construction, reduced cost, reduced disruption, noise, and waste on site, which is the big one. And then optimal solution for affordable housing, because there's such a reduced cost with this construction method. It is the preferred construction method for affordable housing, and you'll see a lot of these affordable housing complexes start growing up in cities that are mostly designed via modular construction. There are some disadvantages though, and that would be the site must be easily accessible to transport trucks. So if you're building a home in the hills somewhere, if a truck can get to it easily, just don't consider modular construction, just build it on site. And then finally, restricted design flexibility due to shipping. This, I would say, is mostly for those types of buildings that are built like Legos, just everything's just kind of built on top of each other, kind of like this. But there are ways to design homes that are like single family homes, especially, that are that look like normal homes. It's just that it's like they take a normal home, they slice it up, and then they ship all the parts of it. So that's one way to do it. And in that kind of scenario, you don't really have restricted design flexibility because you're designing the same types of homes you would normally. There's a lot more coordination that has to be done in the very beginning to ensure that there's no like issues related to shipping these components one by one. Yeah, and also modular construction has been more common in the multifamily housing market, but like I mentioned with that, that type of home that's built in pieces, um, it is gaining more traction in the single family housing market as well. And so here's one example of modular housing. This is the Steinberg Hart's building in Las Palmas project. It's a modular apartment block, and it was designed by Steinberg Hart. So with escalating construction costs stemming from widespread labor shortages, that's kind of pushing developers to embrace factory-built buildings in order to save time and money bringing their projects to life. And so, like the first picture that I showed looked kind of like barren, looked kind of, very sterile, looks kind of like a hospital even. But there's ways to make modular construction look very attractive. Like personally, I would want to live here. And there's another modular building that I'll show you in a while in the next section. But there's ways to make it look very attractive. And so this is one example of that. And I'm sure everyone that lives here, is having, that doesn't even notice that it is a modular building because they look kind of like every other building. Just most apartment buildings are just blocks anyway. So it's just an interesting solution, I would say. And then my favorite, this is 3D printing construction. So 3D printing is, a 3D printed home is a building that's made up of walls that are printed layer by layer out of various materials, such as concrete, mortar, special polymers, recycled plastics, and even soil. There are a lot of advantages, such as the versatile nature of the printing process, which unlocks a new level of design. And so this building over here, which the next slide will kind of talk more about, is called House Zero, and it's designed by Lake Flato and Icon 3D. It's currently like one of my favorite residential buildings because of how unique it is. Like there's no way to design this type of home without a 3D printer. So that's a huge advantage, I would say. Also, there's lower construction costs because the only crew you need is just there to make sure that the printer is behaving correctly and installing circuits where they need to go and placing ducts and all of that. But besides that, it's not, you don't have bricklayers or any of that. And then also faster construction. Again, you can print these homes in probably like 2 days, depending on the environmental conditions of the site. And also reduced construction waste. That's a big one. This isn't your normal stick build building. So there's not a lot of waste that's going to be generated. And also because it's so affordable or so cost effective, it can be used for affordable housing. And I'm going to talk about that as well in the next section. There are some disadvantages though. So some engineering and architectural compatibility, that's a big one. So a lot of engineers and a lot of architects have never dealt with this type of building before. I'm not sure if any of you all have, but if you have, let me know. But because of, there's not a lot of experience in the industry with it, it's hard to design for it and to create the drawings to create a building like this. And so traditional blueprints are not compatible. Therefore, the entire design process needs to be reconsidered. You can't just have 2D drawings anymore. You actually have to say show a 3D model to your owner and say this is how it's going to look. You can do like side you can create renderings like this one. I think this might be a rendering, I'm not sure, and illustrate that, but you can't do that normally with a blueprint. So it's just an entirely different way to design. And also finally, printing process requires constant attention and good environmental conditions. So if it's raining too much and the material that's being printed is primarily concrete or cement, then that'll cause it to be more slushy than it should be. So that's another thing to consider. And so here is a cutout of that same home that we were looking at. And like I said, it is called House Zero. And the reason why it is because it is a zero net energy home. This home is located in Austin, Texas, which is where I studied. And it was designed by Icon 3D, which is also based in Austin. And they're currently building a whole neighborhood full of homes like this. Not exactly like this. This is kind of like the prime example of what they can build. And I think it's going to be a lot more common in the future. But yeah, essentially, the envelope is thermally broken and robustly insulated. The curvilinear walls are more structurally resilient than traditional walls because curved structures are more structurally secure. And then also the MEP systems integrated into the structure. So the MEP systems are integrated into the structure of the home. And you can see that over here, which I thought was super cool. And then it's also designed to accommodate building integrated photovoltaics, or BIPV. And then the entire building has high efficiency home appliances, which help it attain the net zero classification or status. And so, yeah, definitely give them give their site a look. This is where I got this graphic from. And yeah, look at the work that they've done. And so the next thing we'll talk about is affordable housing. And so I'm going to talk about multifamily and also single family homes. First, multifamily living. And so this is a building in Denmark, and it was designed by Bjarke Ingels Group, and it was recently completed. It's a 66 unit affordable housing development, and it's made out of stacked prefabricated modules. As you can see, it's gorgeous. Like it's a very nice building to live in. And I think the entire building cost only about, I think it's about $10 million, which is a very low cost. And some key takeaways from this type of project are that this new construction technologies and techniques are making it easier to design beautiful, high-performing, affordable homes. And so for the first time ever, it's now possible for affordable homes to be made very attractive. Faster project turnaround reduces risk for affordable housing developers, and more affordable housing reduces local crimes, it improves general welfare, and boosts the local economy as well. And if you look at some, if you look at the statistics about Denmark, that kind of makes sense. It's a very peaceful place. It's actually where I currently am right now. I'm doing this webinar from Europe in Copenhagen, and I've actually have seen this building, which is why I'm kind of showing this off. And then finally, for single family homes, this is an example of what 3D printing can do for the affordable housing market. So this is Icon 3D again, but it's a collaboration between Icon, New Story, and also Echale. And so this is a home, like an entire 3D printed neighborhood that they designed for, I think it's about 50 families. And each of them are 500 square feet, and they were 3D printed by Icon's robotic software and advanced material, which is kind of their patented material. And so some key takeaways from this project are that traditionally affordable housing has largely been multifamily buildings, but those that are less fortunate are also deserving of the benefits of a single family home, which are like more privacy, just the ability to call the entire space your own. Everyone's deserving of that. And so why just have that, why make affordable housing just be multifamily? Everyone deserves the option to choose what type of living conditions they want to have. And also, because 3D printing technology exists, that has enabled the construction of affordable single-family homes all over the world, allowing for a new level of comfort that was never once attainable. And so, yeah, this neighborhood is located in Mexico. If you want to learn more about this entire project, there's a documentary called Homes on Apple TV, and there's one episode called Mexico, and that's where I learned about this project. It's super cool. Made me tear up because it's so that, you know, all these people, that all these families were basically unhoused. They had they were living in really terrible conditions. And so this company, New Story, essentially, you know, restarted their whole lives. It gave them a home to have forever, and for, you know, for them to pass down through generations. And so it's just very moving, and I can't wait to see what the future of residential architecture looks like with all of these new technologies, which is kind of why I created this whole presentation to begin with. So yeah, that's kind of the end of my presentation. And so if anyone has any questions, definitely, you know, ask them. This is your time to do so.